Into Math 3rd Grade Lesson 2.3, Relate Area to Addition and Multiplication. The I can statement is I can use repeated addition or multiplication to find the area of a rectangle. Please gather your workbook and a pencil and turn to page 43. When you're ready, we will start at Spark Your Learning. As usual, we will read and highlight and underline the important information. Zenda draws 3 designs for a game board. She wants the game board to have an area greater than 12 square centimeters. So we'll underline that important information and circle that. Which design should Zenda use? So that is what we're looking for, the design that Zenda should use when her area is greater than 12 squares. And it says, show your work, and they give us design A, B, and C, and they let us know that each unit square represents 1 square centimeter. Okay, so if you would like to pause this video and try it on your own and come back, you're welcome to do that. Otherwise, you can follow along with me. So my first step is to look at these designs and find out what is the area or the amount of units covering each figure. So the first thing I'm going to do is look at design A. I'm going to go ahead and count each unit. And by doing that, I'm finding out what is the area for design A. And I end up with 10 square centimeters. Now I'm going to look at design B. And I'm going to do the same thing, but I'm going to number just the top. Okay, so the top has 7 square centimeters, but I know that the top is exactly like the bottom, so it's almost like I don't even need to write those in because I know that it's going to be 7 plus 7 here because I know these are exactly the same. I could write them in if I wanted to, or I can just say, I know that this is 2 rows of 7, or 7 plus 7, which is going to give me 14. So if you want to check that, you can by counting each square, but I've done a different way by showing that there are 2 rows of 7, and I've written 1 through 7, 2 different times. Now I'm going to look at design C. And I notice that there's 1, 2, 3 across the row. And I notice the same thing here that I can do the same thing. I can write 1, 2, 3, 1, 2, 3. So I have 3 groups of 1, 2, 3. I have 1, 2, 3 groups. So I really have a multiplication equation here, 3 times 3, which would give me 9. I can always count these again if I'd like, or do 3 plus 3 plus 3. Either way, I'm going to get 9 square centimeters. So taking a look at what they're asking, which is saying which design should she use, and it has to be greater than 12 square centimeters, it looks like the only design that is greater than 12 would be this one right here, design B. So I'm going to answer this question, design B, when it's asking which design has an area that is greater than 12 square centimeters. Please turn the page to page 44, and let's start under Build Understanding Question 1. I will read, and let's highlight and underline together the most important information to help us solve this problem. Monty uses unit squares to measure the area of a game card. Each unit square is 1 square inch. That's very important information. He makes the drawings below. What is the area of the game card? So that is what we're going to try to find out, is what is the area of the game card when each square unit is 1 square inch. And then the directions ask us to show 2 ways to find the area of the game card. Question A says, what unit of measurement does Monty use? And question B, what methods or operations can you use? So we have the 2 game cards below, and we're looking for ways that we can find the area. And so just like before, you can always pause this and try it on your own and come back, or you can just follow along with me. I'm going to show you a couple different ideas. So I'm noticing here, just like before, that I could go ahead and fill in the numbers across the top. And when I do that, I see that I have 6. Well, I know that these are identical or exactly the same. So I can go ahead and write the same thing here, 1 through 6, on all of these squares. And that tells me, sometimes it's hard to do with this pen, and that tells me that I really have 6 plus 6 plus 6. And when I add 6 plus 6 plus 6, I will always get 18, and that is square inches in this example. All right, now let's take a look at another way that we can solve this problem. So here I see that I have 1, 2, 3 rows. And remember, rows are like a rowboat. Here's the boat and the water. We go across. So I have 1, 2, 3 rows. And in each row, there are 6 squares. So we have 3 rows where there are 6 in each row. And so when we make this multiplication problem, that's 3 groups of 6, and that's going to give us the number 18, which is the same thing that we found here. We just used a different way. So let's go to the questions. What unit of measurement does Monty use? Well, they told us that here when they said that each unit square is 1 square inch. So we can answer that question, square inch, here. And then B, what methods or operations can you use? And I'm going to write down here that I can count the squares, which I've done before. I can add the squares where I made 6 plus 6 plus 6. I added all those together. I can also create a multiplication problem, which I did here below, where I can multiply. And it's asking question C at the bottom, what is the area of the game card? And we have already solved this. So you can write that in, 18 square, and then remember what the unit was, inches. And that was given to us up here and in the word problem. All right, let's go to the next page. On page 45, under Step It Out, question 2 reads, Tammy uses unit squares to measure the area of a floor mat. So she's looking for the area of a floor mat, and she's using unit squares. Each unit square is 1 square foot. So that's very important to know what we're using to measure that mat. And it's asking what is the area of the mat. Question A, use repeated addition. What number do you add each time? So they're asking for the number we add each time. And how many times do you add the same number? So let's take a look over here. We have our mat, and we know that each square is 1 square foot. They give us that key here at the bottom. And so if we're taking a look at this, I'm noticing that there are 1, 2, 3, 4 in the row. And how many rows do we have? We have 1, 2, 3, 4, 5. So I'm noticing that I'm going to have, we can write these out all the way if you'd like to to do that, you can if that helps you to see the problem better. But I'm noticing that there are 5 rows, and in each row we have 4 square feet in each row. So this first question asks, what number do you add each time? So we are going to add 4 each time because that's the amount in each row. And so I'm going to add 4 plus 4 plus 4 plus 4 plus 4. And if you count those, that would be 5 times. And when I do that, you can count by 4s, you can count them all together. You can pause the video and try it yourself. But when you do that, you're going to find that there are 20 when you add 4 5 times. So the area is going to be 20 square feet. And that's one way that we can show how to do this. The other way asks to use multiplication. It wants to know how many rows are there and how many squares are in each row. It asks us to write the side lengths on the mat. So we are going to take a look at the same floor mat, and we know that there are 1, 2, 3, 4, 5 rows here. And we know that in each of those rows, 1, 2, 3, 4, there are 4 in each row. So we can answer this question by saying there are 5 rows and there are 4 squares. And then we can multiply and we can write down 5 here and 4 here for the 5 rows and the 4 squares. And when we multiply 5 times 4, we are going to get the answer of 20, and that's the same answer as above, it's just in a different way. So the area of the mat is 20 square feet, and that's because we used this information here and also here to find out that important part about the area. If you would like to go back and re-watch any of this video, you may do so, and you can pause at any time.